let's start with this one. What should be the name of that molecule? I mean, it's a cycloalkane. You can see that, right? So we have a methyl substituents, ethyl substituents. How we should number? So if you number this way, the 1, 2, 3, but you can also number the other way, possible 1, 2, 3. So either way, you're going to get 1, 3. Which one's better? Which 1, 3 is better? I somehow show you only the correct one here. But this one, 1, 3, if you number this way, if you make this one number 1, that becomes a 3. So we have to make a choices of which way it has to go. You cannot break the tie with a rule number 2, because in both ways you get a 1, 3 system. So you're going to use a rule number 3, the name of the substituents. The first alphabetically appearing one should get the first priority. This is an ethyl, start with an E. That's a methyl, start with an M. So that's the reason we make this carbon as number 1, that number 3. So name of this one, 1-ethyl, 3-methyl, cycloalkane. So what I did the previous years, I solved these problems in the class, and then at the test, I asked this question to you. It looks awfully the same. They almost identical. If you have slip looking at this question, me solving it, you're going to see that, oh, that looks the same. And then I remember that he pointed out that ethyl starting first. So I make this one number 1. So you should make that one number 1. I'm pretty sure that you know where I'm going. It's easily fall into trap by just having one method, just one change will completely change something. So that numbering system same as that one, but the problem is now you've got 2 methyl groups, not just 1. If you number this way, it's a 1, 3, 3. If you number the other way, even the methyl starting later than methyl, this numbering system you get 1, 1, 3. So which way is better? For instance, if you're using the same numbering system, the carbon with the ethyl number 1, you get the 1-ethyl, but 3, 3-dimethyl. That's the part, it's different. It's just 1 substituents, 2 substituents, makes a difference in the number. On the other hand, if you number this way, 3-ethyl, 1, 1-dimethyl, and then your job is trying to make the number as low as possible, right? So that, simple adding method, change number. I mean, if you don't answer that way, I give you the partial credit. But still, it's not the full credit you will get. I hope that you look for those type of situations, not falling into trap you rely on. Any question on this? Yeah, I mean, because these numbers are, you got 113 is lower than 100. That's the reason. It's not the alphabetical ordering as this one. That one is either 1, 3 or 1, 3. So that way we use the next rule to break the tie. But in this case, we can break the tie from the rule number 2 because the 1, 1, 3 is better than 1, 3, 3. It can be very subtle, but make a big difference after the chemistry. The similarity doesn't work. If you argue with me, I see some question looks pretty similar, and an answer key is like that. Why can't I solve it this way? And then you basically find all the things about organic chemistry. Subtlety. That's what you've got to be careful about. And then that's what you look for too. All right, moving on. What would be the name of that molecule is pretty simple, more easier than that one. This one, it becomes a cyclobutane, what's the main chain? Cyclobutane is only 4 carbon. If you count this chain, that will be much longer, right? 1, 2, 3, 4, 5, 6, 7, 8. It's an octane will be bigger. Should I count going this way? You cannot count in and out of the that way. It gotta be continuous. So it's gonna be the octane, and then the numbering should be from here, but that way this will become number 4 instead of number 5 counting the other direction. What about this one? That's gonna be a little bit of a not simple, not fast answering as this one. Cyclohexane, definitely it is. It's a cyclohexane. But we got many substituents. So now which carbon gets number one? That's probably the most trouble spot right there. Should I make this one number one? Or should I make that one number one? So you gotta think about all the possibilities. If you make that one number one, it's 1, 3, 4, 5. If I make that one number one, it's 1, 2, 3, and 5, right? Or actually 1, 2, 1, 2, 4, and 6. So probably better to put either this one or that one as number one. Right now, this one and that one is the same nitro, doesn't matter. But if these two become different, then you kind of have to choose the one that starting alphabetically first should be number one. Yeah, because that's definitely is symmetrical. So either we start here, you get the same number. If you start from that one, you get the same number. The best way is that you try to give a name, starting with this one, and then number this way, make up the name. Starting with that one, and then put it this way, make up the name, and you're gonna find out it's exactly the same. Oh no, and why we should start from here is array numbering to 1, 2, 3, and 5. So you can make number 1, 1, 2, 3, 5. So there's a two different ways to count the 1, 2, 3, 5. One counting here and going this way, or the other one starting here and going the other way. But it's gonna be the why I didn't pick this one as number one is because of 1, 2, 4, 6. Numbers definitely bigger than the other one. If you count either this one number one or that one number one, 1, 2, 3, 5. So when there's a multiple substitutions, you really have to entertain all the possibilities and try to figure out which one's the best. So I know this just a sheer numbers makes it difficult. But as I said, if I solve these things, and then if I want to make it, if I want to raise a notch up of the difficulty level, then what I will do, I'll change this nitro as a method. Then it won't be same anymore. You gotta count number one wisely. Because if you have a different one than nitro, 1, 2, 3, 5, 1, 2, 3, 5 is the same numbering system, but number one becomes different. So how are we going to sort it out? The next rule. The one that alphabetically studying first should get number one. So it's always looking for the high and how to break the time when there's any kind of ambiguity there. So anyway. Drawing the structures is much easier than naming in a way, because you see that the cyclohexane as a parent chain, then what you can do, just draw the cyclohexane. And then 3 ethyl, right? So number 3 position here should be ethyl, just one, because we got just one ethyl. But the 1,1 dimethyl means that we get to put 2 methyl groups and the carbon number 1. So drawing is basically much easier. But you can draw this thing in any way you want. You can put number 1 down here, but it gotta be this one number 3 or that one number 3. So multiple different drawings, they're all the same as long as you meet same requirements. The next one's a cyclohexane. But we got 1, 2 dichloro, 4 nitro. So if I pick this one number 1, 1, 2 dichloro, and the 4 nitro, nitro must be the number. So things like that.